Okay, for the first question, so here is the function given by the question. So the first step is we need to find this question. We need to find the del x, del over del y, and del over del z of this function, and then we just arrange it in term of ijk, and we straight away get the answer. So for cross product, we need to solve it using the matrices problem, and then make sure that we follow the sign and make sure the sign is correct, and then we will get straight away the answer. For this case, we need to find the del of del f first, just like the first question. So we just can copy the first question answer, and this will go like this. For B, the question is asked us to find the acceleration for this function. So the condition is at t equal to 0, point is 1, 0, 0, and at v0 is equal to 2i minus 4j. So for question Roman 1, we need to integrate acceleration to find the velocity, because to get as from velocity to acceleration we need to differentiate, but from acceleration to velocity we need to integrate. So integrate negative sine t plus t exponent power of t, we will get this answer. And then to find the r, means radius, we need to integrate velocity, then we will get this answer. So this is the function of the range. And then the question asks for velocity at t equal to 1. So we just substitute from the v that we get from the question first Roman, we just substitute 1 in the replace t with 1. Okay, after we replace t with 1, we will get the velocity. For this question, for C, first step is we need to differentiate every function in here, okay, in term of x, y, and z. So then we will get this lah, I, j, and k. And then we know that the question is given like at point 1, 1, 1. So at 1, negative 1, and 1, we substitute the value with the value x, y, and z, and then we will receive this answer. So we continue to find the du v, and then we will get 15 for the answer.
For question 2a, it is regarding the line integral of vector field. From the point given, we can find the RT. Then from the RT, we can find the limit of t. Then after that, we find the dRT. After that, we sub all the information into the equation, which is the total work done. And the equation is integrate f1 dx plus f2 dy plus f3 dz. Then we solve the integration. For question 2b, it is regarding the conservative field. To show that the force field is conservative, we need to show the curl F is equal to 0 by using cross product. Then to find the potential function, we need to integrate the f1, f2, and f3, and then we plus together to obtain the potential function. Then to find the work done, we need to sub the points into the potential function and total up. For question 2c, it is regarding the Green theorems. Firstly, we need to solve the equation given by completing the square. Then we sketch the solid of integration and find the limit r and limit theta. Then for the Green theorem, the equation is shown like this. Then we sub all the information into the equation and solve the integration.
Okay, this is question from semester 2, session 2019-2020. And my question is question 3. As you can see, this question is about surface integral. So we go ahead to question 3a. This is my answer. Okay, the question need to ask to find the area of the curved surface of the paraboloid in the first octave. Okay, so right down here, first octave. So you can find the shape, the graph, 3D in first octave. So what we can get here is the theta will be pi over 2, r equal to 3. The radius will be equal to 3. Okay. So first, we need to find the f. This is z minus the equation in here in z. Substitute, and this is what I get. And then we need to find the gradient f. We need to differentiate one by one in I, j, and k. So this is delta f. Differentiate f with respect to x, differentiate f with respect to y, and then this with respect to z. So after differentiate, we will get this one. And then we need to find the ds. So ds is this formula, gradient f, and then dA. So dA is fixed. So use this, and then this is what I get from here. Next, this is the equation. This equation. Okay. ds, substitute ds, and since we didn't have the f, so let's put it here. So r dr d theta, and then the limit is 0 to 3 because our r is from 0 to 3, and then theta is 0 to pi over 2. As you can see, 0 to pi over 2, our angle theta. Substitute. So this r squared because x squared plus y squared equals to r squared. So simplify it. So for set for r squared plus 1, and then I simplify again, move 4 from r. Okay, so this one is set 4 become 2, and you can do the integration to this out. So in here I let u equals to this one, r squared plus 1 over 4. Use r squared here because this one is r squared. We want to integrate the r squared. So this one, so it becomes this, because this one is u 1 over 2. So if we integrate 1 over 2 plus 1 become 3 over 2, and then over 3 over 2. So it's actually will be 2 over 3 u, and we substitute u. So we got this. We get this. Substitute the limit r, and then we do the pi. Integrate. You get this theta. So theta here is equal to pi over 2. And then this is the answer that I get. That I got. Okay. So the next question is using Gauss theorem, you need to evaluate this, where fx, and then closed surface of tetrahedron bounded by the plane x plus 2y plus z equals to 4 in the first octane. So this is the graph, 3D graph, the shape, the graph in first octane, the tetrahedron. And then the equation of this Gauss theorem. As you can see, this one is flux integral and this one is flow out of small cubes. Okay, we find the diff f first, 1 plus 2 plus 3, 1 plus 2 plus 3, and then we want to find the area of tetrahedron, split the area. So 1 over 4 is because it is first octane. So this one is in order of dz dy dx. So the limit of z is from 0 until to 4 minus x minus 2y, because this one z range, and then we get limit z, and the next one is dy. So from 0 to 2 minus x over 2, again we rearrange this one, and then we write the z is 0. We can get this. It's actually y equals to 2 minus x over 2, and then the x, so this one is simple, 0, 2, because it is 0, this is 2. Okay, and then we do the integration one by one, and you will get 7 over 6 from this integration. So we need to find this one from this one. So we do this one. So we need to times 5 here, diff f, times the answer here, and then you get 35 over 6. Okay, for 3C, the question is okay, surface of the cone is this one, yeah, equation of the cone, and orientation counterclockwise looking from above, and we need to use Stokes theorem. Okay, so Stokes theorem, sorry, oh yeah, so we know that this one from Stokes theorem is equals to this close one, close curve. Okay, so we need to find this again. We make it more simplified for f1 dx, f2 dy, f3 dz. So f1 is from here, f2 is from here, and f3 our we don't have the k coordinate k, so 0, yeah, so 0. And then you can see that from xy plane, this is looking from above. We can get the from z equals to 2, and by using this equation we can get that x squared plus y squared equals to 2 squared, which means the r is 2. Okay, so again the theta is from 0 to 2 pi whole revolution. And since this one is a curl, we know that x equals to r cos t, y equals to r sin t. Okay, so we write here that our r is 2, so x equals to 2 cos t, y equals to 2 sin t, and our z is from here. zx squared plus y squared. Again, it will become r squared. If you cancel this one, you get r is equals to 2. And we differentiate it. And we get negative 2 sine t for differentiate aspect x. Dy dt, 2 cos t, dz dt, you get 0. Okay, so substitute to the equation here from this one, from this equation. So this one is x squared. We differentiate x values, y squared, we differentiate y's values, and z, again, z values, which is 2. Again, the limit is 0 to 2 pi because our theta is 0 to 2 pi. So we substitute the corresponding values, and then we get this. Because this is too long, we can do it one by one. We can let this one become A, and then this become B. So this one is A. Okay, we do this. So you know that cos squared t plus sine squared t will become 1. Okay, and then this become negative 8 sine t. We integrate, it will become negative cos t, and then negative become positive, 8 cos t, limit to pi 0, cos 2 pi will become 1, so this will become 1, 8. Okay, so B, again this one, from this, 4 times 2, 8, 8 times 2, 16, differentiate cos t becomes sin t, and then sin 2 pi will become 0, so this one will become 0 clearly. So to find this, so we just a plus b, so a is 8, b is 0, will become 8. So that's the answer. Thank you.